Today I'll be giving you a brief history of the Tamarisk Beetle project here in western Colorado, along with some monitoring questions and results to date, and future outlook and goals. So first off, this is just an overview of our site setup. So we take 25 marked trees per site. And this is based on the original beetle monitoring protocol by APHIS. So we've taken what they've given us and modified it to fit in more sites. So more of a quick and dirty, but we do spread our trees across approximately 400 meters. So we get pretty good sample there. And here's just a look at our 12 sites here in western Colorado. You can see they range across western Colorado from south, where Bedrock is located, all the way towards a site near Parachute. So we've also started to set up sites in eastern Colorado, which is exciting for us because we're watching the spread of beetles through that part of the state currently. We've been working to get them established there, and so we're now up to 6 sites in eastern Colorado, so we will keep track of those as well. So here's a map showing those site locations, and those were, we began setting those up in 2008. So our objectives are to measure damage to the canopy or the leaves of individually marked tamarisk trees, as well as percent flowers per canopy, along with dead biomass or dead branches per tree, and approximate beetles, adults, and larvae per tree. And it's a quick and dirty, it's a rough estimate. It's using visual in situ estimates. But we get within a pretty good range, so we can say if the tree is damaged, 1 to 10% versus upwards to 60 to 80, and high damage of 95% to dead. So it's somewhat of a rough approximation, but it gives us the information we're looking for. And here is a look at the phenology through time at 5 of our closest measured sites, so meaning that we monitored these more frequently than other sites we couldn't get to as often. So we made it to these places a little more frequently, and I'm going to start with 10 and go through to 13, but I should preface this by saying that we had good beetle numbers in 08 and 09, so they slowly built over time. From 07, we started to see them cross the Utah border, and they've built steadily from that point. So 08 and 09 were both good beetle years, and 10 as well. We saw a dip in our populations in 11, and they were back up again in 12. And this also demonstrates when we typically see the overwintering adults come out in the season, which is late April to early May, and also this allows you to see that we see 2 new generations per season here in western Colorado. So whereas some other regions in the country see, I think at least 3. I know at least 3 generations in some places, but here we just see two per season. So again, we I'm sorry, that was the larvae, so I should have explained that better. This is showing larvae abundances, and these are the adult abundances. So here you can actually see the overwintering generation out at least by early to mid-May, and also the first generation and second generation, which build through the season, and it's those first generation adults that are out in early to mid-July, and those are the beetles that we're collecting the most of because they've definitely built by midsummer and they've damaged the sites as pretty much the most through the season. So here's just another look at that, at the numbers through time. And this top plot starts in 10 and 11. And you can see we had really high beetle collections. So these are the beetles that we collected here in western Colorado. And we collected really, really high abundances in 2010, which were shipped to eastern Colorado. And in 11, we saw a huge dip in our populations. And we speculate that that's possibly due to the build over time from 07 to 10, and along with also climate could have something to do with it too. It's a really wet year in 11, so ultimately we saw a big dip there. And in 12, we see another rise of number of our beetle abundances. And in 13, we set the record for most beetles collected and shipped to eastern Colorado with over 600,000. So it was a huge beetle year this last season, and we definitely noted the damage to Tamarisk all across this region. Everyone who works here in western Colorado definitely saw the results of that high defoliation through by the first generation by mid-July. So that was exciting, and it's just another view of beetles collected. I do want to point out that we collected most of our beetles from the Dolores watershed in 08 through 10. We initially released beetles in 07 that were actually raised at the insectary. So we started with really low numbers, those built through time, and possibly, well, most likely were also joined up with populations moving up from Utah. And so, again, they built steadily through time, and 11 was a slower year for beetles, but they picked back up again in 12 and 13, where we collected here in the Grand Valley. So let's just give you some quick visuals of our gateway site, because this is one of our initial sites on the Dolores, and we started releasing in 06 here, and by 13 we saw really significant damage to the trees. But on the picture on the bottom right is interesting, because that's regrowth, which you've all heard mentioned quite a lot here, because that's really interesting to the whole story, is that these trees are, even though they look so damaged and dead, what we're seeing is that often most are still alive, or at least a large abundance are still alive and able to refoliate within a season. So here's just another look at a site on the Dolores, the Bedrock site. And again, we see really healthy looking tamarisk in the onset of the project. And to date, it looks devastated, looks damaged, looks dead. In fact, it's still alive for a lot of the trees, particularly these shown. They're the same trees tracked through time, and the bottom pictures represent 2013 photos, and those trees look really dead, but they're not. They're alive. So, of course, they're almost dead. They're somewhat living ghosts, but they are in fact alive. But what's important about this is that all that dead biomass is ultimately what we were after anyway, because ultimately that's going to open up the canopy and allow, sites that are and have a diversity of natives, which is not always the case, but sites that do have some native diversity might be able to get more recruits, more native recruits in where that canopy has opened. But something worth noting along the way as we're measuring this dead biomass is, and the top plot actually shows a decrease in green canopy. So the canopy, just the two widths and height of the green canopy per tree, measured in '08 paired to the green canopy measured in 2013. So you can see quite a decrease at Gateway and Bedrock. But one of our sites, we call the Gunnison site, which is actually located in Rattlesnake Gulch, so near Delta, it actually has not been damaged at all, low to zero damage through time. And so that's somewhat acted as a control for us, which is interesting. And you can see that we actually had an increase of green canopy from what was measured in '08 to 13. So that's kind of useful information because we can see that the canopy actually increased. So on the bottom plot, we're looking again at dead biomass, or dead wood, dead branches per tree. This is the mean across Gateway and Bedrock. And something that may have given Bedrock an edge, because Bedrock ultimately has higher mean dead wood, dead biomass, is the fact that Bedrock got defoliated by beetles in the end of '08. So whereas Gateway got defoliated near beginning season, which we often see, Bedrock actually was defoliated towards the end of '08, and that may have been in part, it's not, certainly not the main cause, but could be part of the story as to why we see such a spike in dead biomass at Bedrock. So that's been observed again at other sites, such as Stanyang Unburned, where we saw another nice spike of dead biomass in in 11, and that site was also defoliated towards the end of the season. So that may have helped to increase that dead biomass that was measured in 2010. So it seems to be a correlation there of when the beetles hit, when they defoliate, which really is picking the low-hanging fruit. Of course, that makes sense, but it is interesting to actually see that, to measure that. So what I'm getting at here is that we've seen their numbers build over time. So we saw 12 being a really good beetle year. This last year was a great beetle year. So what is the result of these building numbers through time? So here's just another look at 12, which was a really abundant, had high abundances of beetles across sites and also collected. And we did see at least a leveling off of damage in 12. So we continue to see dead biomass, but it's not as much of an increase as you would think you would see, and that's due in part because 11 was a lower beetle year. So because they didn't damage the sites as much in 11 as our abundances were lower, we actually see that those lower abundances reflected in the damage to Tamarisk in 12. So what we measure in 12, even though we had high beetle abundances, we actually had not as much of an increase in dead biomass as you would think, because that damage is reflected the following season. So that's kind of another interesting thing to note. And that the pictures at the top just represent that. We did not see refoliation in Gateway in 11, whereas Bedrock we did. And we saw the same thing in 13, whereas a site such as Salt Creek 1 that got defoliated late in 2012 had a major increase of dead biomass in 13. So we were pretty excited to have that site undergo defoliation because it's been one of our healthier sites along the way. So we were really excited to see that defoliation occur, and we saw a nice spike in dead biomass in 13. And here's our mortality across sites in western Colorado. So it's not as high as you would think. From what you see in the field and seeing all the dead looking tamarisk, it's pretty surprising. It's not dead, and it's actually doing okay despite these consecutive defoliation events. But it is worth mentioning we have seen mortality up towards 50%, which is good, substantial, helpful, but it's not as high as you would think. Although dead biomass at our site with greatest mortality is actually measured at 80%, so 80% dead biomass. So we wanted to check what may have caused some of the differences in not only dead biomass, but mortality across sites, which were defoliated the same amount of times. And we actually found that tree size wasn't significantly different, so that wasn't one of the causes. We measured distance from open water, which isn't the best measurement. It would be better to measure water depth, but we just wanted to check that. And so those didn't seem to correlate, but whereas maybe water depth or tree age might be better measurements. Seasonal timing does seem to have an influence on dead biomass and the following season, and then ultimately tree mortality. But again, it's just correlative data. And other scientists, Dr. Kevin Holtine and Tom Dudley, are looking at tree genomics, so that could have influence. And just, I'll speed up a little, and just wanted to point out that ultimately, even if the trees aren't actually dead, this dead biomass is a fortunate outcome for this biocontrol project because it is opening up the canopy and leaving room for those more desirable plants, especially where restoration techniques are implemented. So we are happy with the level of control the beetles are providing, and they are even decreasing percent flowers per canopy as well. I didn't show a plot for that, but that's worth noting too. So, so we're happy with the long-term control against further spread in watersheds where they've established, which is pretty much all of western Colorado, and we're focusing now on eastern Colorado. Uh-oh, I am out of time. So, okay, so and just really quick, we have seen that mulching can result in a lot of regrowth, even though if it's timed right with beetle damage, it can help to control, but it can just add to healthier, more vigorous plants too if it's not timed right or the stumps aren't treated. Okay, that's it. Thank you.